Hey everyone, I thought I would try something a little bit different for this. Rather than spend weeks and weeks trying to edit my video, doing multiple takes and getting nowhere, I thought I would just stream my progress. So here I am. I'm a little bit of a perfectionist when it comes to making videos. Like I'll try and get my points across, but then I'll stumble and turn the record, hit the stop button, and I'll just get into a loop of not being able to get my point across or get anything done. So terrible. So I just decided to do a live stream of this, and then hopefully later I can take this and I can sort of edit it down, and that'll be the episode of the progress report. So anyway, I've got quite a lot to update everybody on. I've made some good progress on taking Rebound, the game Rebound and the engine, and porting it. So the original part of the plan was to port Rebound from SFML to SDL, so from the simple and fast media library to the simple direct media layer library. Reason for that is because SDL can be then compiled down to WebAssembly, and the end goal is that I can make the this one of my old games work as a web app, kind of akin to how games used to work in like Flash Player. Essentially, it'll just use the canvas, but yeah, it just seems like a really cool little project to work on. So, in terms of progress, I've fully ported, as you can see here, I've fully ported my engine from SFML to SDL. I've also got this set up with a make file now, so that, it's a huge make file, that I got a little bit of help using, I think it was CBP to make file as like a tool that you can use to run on a code blocks project. So that was kind of how I started with that, and then I used that to make a make file, and I've just like heavily customized it now. So this builds an SDL now, and it works fine. So we can go ahead and do a build just to demonstrate that. So I can do a debug build. I'll just do this at the command line. So if I just type make debug, so go ahead and build the engine, and build the game as well using the engine. I should be able to run it. Just a second. Yep. So this is where the build's been generated, and if I go ahead and run that, we get the game. Hopefully, you can hear the audio. I mean, it's an awful theme tune that I made in Dance EJ many years ago. So maybe it's better if you don't hear it. But here's the game building as an SDL project in C++ on Windows. Nothing stopping this working on a Mac or Linux as well. You just have to compile it down. So input works, graphics work, audio works, everything works. It's brilliant. Yep, cool. And the good news is that it actually wasn't that hard to port the engine from SFML to SDL. Like, I did spend quite a lot of time 10 years ago architecting this project so that it would, like this engine, so that it would be sort of, well, I never had a goal of changing the library, but I kind of made it nice and decoupled and modular, and I use a bunch of like design patterns and stuff to make it sort of nicely decoupled. So because of that, actually ripping out the media library that it uses wasn't that hard. A good example is we have like sprites, if I can find that, like the concept of sprite. before it would take like an SFML texture, I think, and now I've just made it so that it takes an SDL texture. And then I had to rewrite all the like window management as well. So you know, I have a concept of an engine in this game. So or in this project. So if we go to the game engine, it does like basic stuff like being able to switch between game states, creating the window, invoking the engine, and you know, here there's been quite a lot of change. Before you would use SDL to create the window and set everything up, but now we're just doing all of the SDL calls. So I also have like an abstraction of what a window is as well. So again, it was really just changing those calls to use SDL instead of SFML, using the SFML mixer library to get sound initiated, and then just setting up initial states. Like this is basically how the code was anyway. One thing that was a little bit of a challenge is getting the loop to work, the game loop to work as I expected again, but that's all working again. You know, just doing basic things like capping the frames, checking for user input. That the user input checks had to be rewritten for each state because they use SDL's events now instead of SFML's. But everything else really just basically worked, so that's pretty good. It really wasn't that tough a project to do. It took a bit of time. I came down with a cold, and I was a bit out of action for a while, and then I went on a holiday, and then Christmas happened. So I didn't actually spend that much time working on this. It was probably, you know, a few hours every so often. And a real old guy problem is every time I sat at this desk, because I have like a desk, like an office where I work on my 9 to 5, and then I have this desk in here, different chairs. Every time I sat on that chair, I would get a bad back. Like, it was really bad. So I persisted and and got some stuff done, but I had to just rein it in and just not sit at this desk because it was absolutely killing my back. So I'm actually using my work chair now, and that's helped things a lot. And I like reposition the monitors and stuff, so everything's I'm just a bit more upright now. So that's how it is. Anyway, that's helped a lot, and I've been able to make a bit more progress, so that's good. See, look, all the stuff I'm saying now would have cut out of a video. You're getting the real insight of why I never get any work done. Other projects. But never mind. Getting back to the point, because we've got to at one point. So yeah, the engine now uses SDL. All the calls are replaced. We've got like a nice, a really good build process as well. So it's just nice and slick. It's great. So that was step 1 of the plan. Actually, step 1 I think was get the thing built in an SFML on a current operating system with the current version of that library, and I did that. Step 2 was to port to SDL, and that's all done now. No more work to do on that. Step 3 was to get scripting working, which is the sort of the tool chain, the sort of development environment tool chain that you use to port C++ apps to web apps. And it has like its own version of the C++ compiler called EMCC. And what you can do is you can use that, and it will compile down a C++ app to WebAssembly, and then you can then use that WebAssembly and also have a canvas element, and basically use your C++ app as if it was a web app. So progress on that, actually quite a lot of progress. So I have 2 projects up here. This is the Rebound engine. Now I didn't want to just start building this in like adding the code to port this to a web app like in the project. It was just a bit too complex. So what I decided to do instead was just do like a slice by slice prototype. So I haven't ported the game to a web app yet, or rather it doesn't build to a web app. But what I have done is I've built a test bed where I've just taken each piece of like everything. Like I've basically asked myself questions I need to validate. The way me is like, actually this is kind of an insight. As a software developer, I'm a very cautious kind of software developer. I like to keep things working as I go along. I have quite a lot of sort of inbuilt anxiety of a build breaking. I work with lots of people, and some people are on the more cautious side, which I am, and other people sometimes are more kind of like gung ho, like they'll just rip a project apart and then get it to work again, and that's a totally valid way of doing things. I'm more on the safe side of things. I like to keep things working, so I decided that I wanted to build a prototype here of like just to test the theories that mscripting actually allows you to display graphics correctly using SDL, play sounds, learn about how things get bundled in terms of the assets into a web app, and in how input is affected and all that kind of stuff. So what I did is I decided to build this extra project. But a useful output of this is that I've now got a Git repo that people can learn from as well. It's just separate from my engine, so and I believe it's a public repo as well. So when I finish the stream and stuff, I'll post a link to that repository, just in case anybody wants to get an mscripting project working. As you can see, I've created a README as well, so it should be fairly easy to get this going. So anyway, I'll talk through this. So first and foremost, you've got to get the mscripting SDKs, and that involves going to the mscripting website and downloading the SDKs. Generally, you just clone the repository, which is what I did. So I just did a git clone of mscripting, and then what that does is it gives you a set of batch files for Windows and shell scripts for Linux or Mac. But what they do is you run those, and it initiates. It firstly updates the SDK, and then it initiates the SDK, and then you use the batch file on Windows to add all the environment variables you need to use the mscripting compiler. Like it puts those in your path temporarily, like in a session. If you're on Linux or Mac, you can take your ZSH RC file or your bash RC file, depending on what you use, and you can actually add that. So it's a bit like your autoexec.bat. You could put that in there, and then it would have those variables in every time, or you could just add them all to your path. I'm not sure if that works. I don't think actually just adding it to your path works. I think you have to actually run something to like a script, and that's what stops you from doing that. But you can put this in your bash RC or your ZSH RC. In Windows, you run the bat file. So you basically run the bat file from wherever you've installed wherever you've added the SDK or you've cloned the repo. Once you have that, you're able to run the mscript compiler. So that's emcc, and it's just saying here at the moment that there's no files available to compile, which makes sense because I haven't specified any. So at the minute, to test my theory of whether the compiler will do what I wanted to do, I've just created a project that has a main source file and then just some other file with some other dependencies in. So I just wanted to test whether I could get a source file and another file that imports stuff working. So real like thin slices kind of situation. So here's my main file. And if you've ever used SDL before, this is going to look quite familiar, but there are some things that are different about this that I had to change to make this work with mscripting. So first thing is, you do have to do an if-def for mscripting. So what, I'm sure people who've done C++ know what an if-def block is, but it's basically a preprocessor command, which is something that runs before it's basically part of the build step. It's like a macro, they call it, and it's like a preprocessor macro. It substitutes strings of, like in the source files, pre-compilation, and it's useful for things like if you want to make something cross-platform compatible, you can specify if-def blocks. And in this case, what you do is you specify this macro here, which is if-def mscripting, and then anything that's inside of those blocks, it will only compile that in like for the mscripting build. So as you can see here, you do have to include the mscripting.h file, which is part of the SDK, part of the SDKs. I probably had to tell Emscripten where some of the stuff was. I did it a little while ago, so it might actually work off of when you initiate the SDK, or you might have to add it to your path. I'm gonna have to double check that at some point. But in any case, my system's able to see the emscripten.h file. So with all that, you basically start off with your int main as you would in a normal C++ app. But what you've got to do is create another main loop file. So, another main loop function. And the reason for that is because, from what I understand, because the web app and Emscripten is multi-threaded, I believe that you have to sort of yield the thread to WebAssembly. I don't know the exact reason behind it. I think it's to do with keeping the render in sync with 60 frames in the web app. But basically it's a little bit different. You have to invoke a different function instead of just running your main function, and that handles your loop. So what I've done here is I've got another if-def block, and it's if you're in Emscripten, it will initiate Emscripten set main loop arg, and you pass it a function, and then some other connext object, and that connext object is just all the stuff that you want to set up in your main on the first run of the project, or the first run of the main loop that you want to kind of carry into the loop. So I've just done a bunch of stuff here, set up audio, and then I wanted to take the title screen for my game, some audio, and just a square that you can control and move around the screen. That's all part of the context. So you do all your setup of SDL, and then you pass in your context, and then essentially if you're running Emscripten, it will set up on that main loop. Otherwise, what I'm doing is I'm just doing my main loop work here. So I have conditions to check whether the user wants to quit or not, and it just does a loop. So basically, Emscripten set main loop arg takes control of that that looping behavior, and again, it's to do with threading. But we set up our own loop here because we have control of the primary thread if it's a desktop app. So yeah, I just do my handle events and my main loop in there, and then once everything's finished, then it'll just clean everything up, get rid of the window, clean up the libraries. So that's good. So yeah, that's one of the differences that you have for creating an Emscripten app. But once you've done that, it's all pretty much the same. You have the same handle events loop here. It just consumes all of the events and then handles them. And then also I've got my main loop here, which just does some drawing. Again, this is just a prototype just to see whether things will work correctly. So yeah, as a result of that, what I can do is I can run a build. Or can I? Actually, that's a good point. Can I run a build? I forgot. Yeah. So if I run make debug, I think this should build. Yes, it has. It's just a really simple thing where I'm passing in some SDL dependencies like mixer, image, and just SDL, and it builds it as an exe. So that's good. But also, if I wanted to build this as a web app, I just have to run. Well, I will actually just remove the original build to show that it works. So here we have a web folder. Created the web folder. This is the last build that I did. I'll just move that, and then in this folder we'll get the build. So I go ahead and I type. I'm just gonna go at the README, and I'm gonna pull out this command, and I can explain the command as well. So here's the command that I got to run. In the minute, ideally, I want this to work in a makefile eventually, but at the moment it's all pretty manual. So what this is doing is it's calling the Emscripten C++ compiler. I'm passing in my source files, and I'm saying that I would like it to generate WebAssembly. I would also like it to use SDL2. I also want it to use SDL Mixer 2, and I want it to use SDL Image 2. And then I also have to specify which formats I want to pass in, and I use PNGs, so that's been passed into there. This is like the optimization level. I think this is high optimization. I'd have to look at the documentation. And then my out file is a HTML file, and what this generates is it's like a HTML file with a canvas and some like debug controls. Eventually, you'd want to replace that with your own like sort of web app front end. Pretty good. But good just having something that builds every time. Personally, what I'm going to do is I'm going to commit a file, a HTML file that just stays there every time, rather than having the debug stuff. At the moment, I haven't done that, but I will do that. And then last but not least, you have the preload file. And what you can do is you can point it to a directory where all of your assets are. And this is something that's different from when I was building my engine. I had you can just basically put the asset files anywhere you want in a desktop app and it'll find it. But in a web app, these need to be bundled. It generates like a manifest file, like a data file. You need to have that stuff structured in a certain way. So what I've done in this project is I refer to everything using. So I've got these directories here. So when you compile this in for the desktop app, it's going to build the project in a bin folder because I tell it to build it in a bin folder in my make file. So what I do in my bin file is I also like debug and release builds, but what I do is I have a mirror version of the asset folder there, so that when you run the exe, it all maps to the same place. So for a web app, what it'll do is it looks for these files, or rather, it looks for these directories. And what I'm telling it to do is to preload the directory here, the whole directory, which is I have this at the root level of the project. So it takes this and it bundles it into this web app here. So if I go ahead and run this now, what it'll do is it'll have all the information it needs to compile the C++ app down to a web app and down to, and it will also bundle all of the assets as well. So go ahead and hit that, and then the compiler just chugs away. It doesn't take too long. As you can see here, it's building up that manifest for the assets, and also a WebAssembly file, and then it has some code to bootstrap the console app, the canvas app. So you got the HTML file and you got the JavaScript file. So now at this point, this is a browser native web app. It's you can host this. You could just chuck this up in a S3 bucket and host it on the web, or you can run a server locally. It's really good. So now what I'll do is I am a web developer, mostly on the front end. I like to use Node.js to run my web servers when I'm testing things locally. But you can use a Python server, or you can use whatever, IIS, I think is the Microsoft one. I haven't touched that in a long time. But I use Node, so Node has a package called HTTP server, so we'll just go ahead and run that. And then all I have to do is point it to, whichever folder that this is in here. In this case, it's the web folder, so I go and hit web. And that's hosted the server. This is all sort of, browser native or browser independent. It's just running a web app as if it was on a server. So now if I go to localhost 8080, there's the game. Or rather, this is the prototype. So in the prototype, what it does is it draws the title screen from Rebound, and then when you click, it activates the audio. And also I can use the keyboard to move around the square here. So essentially, I'm sure you can hear the music in the background. It's kind of not very good. Might have to do a Rebound, rebooted edition or something where I make the music a bit less annoying. So yeah, basically we've got the sort of, I'll just turn that off because then it sounds distracting us. But yeah, you've got all the kind of basic elements of a game working in a web browser. So we got rendering of images and of like primitives. We've got sound. We've got input. It's all like ready to go. Like it's got everything that I need to port the Rebound engine, or my engine in the Rebound game, to web apps. So it's very exciting. I do need to spend a bit of time and like work on that. I might stream that. I might do that in my own time and report on it again. I'm not sure exactly what I'm going to do. Today, I just wanted to make this video because I just keep getting like video maker's block. Whenever I try and record videos, I stumble. But with a stream, it's more conversational. If mistakes get made, you know, I'm not kind of tripping up on myself. So this is why I decided to make this video today. So yeah, where are we on this, on the roadmap? Let me just pull the roadmap up for a second. Okay, so here's the roadmap. So step one was to port or get the existing project working in SFML. Second step was to remove SFML, get it dependency free, and then convert to SDL. So that's all been done. And then the final step was to use scripting to port Rebound to a web app. And I'm essentially at the last stage now. So I have a proof of concept. I just need to change the engine so that it builds to a web app. There are some complications in that. I think the way that my engine's like heartbeat works, you know, the sort of the render loop and the inputs and all that, that's going to have to change because the way the project loops on a web app is different. But that shouldn't take too much effort. I might need to get my head down and figure that out. But we're getting very, very close to having essentially a cross-platform, web-friendly game engine with an example game working, and then from there I can, you know, make loads of cool stuff. So yeah. Anyway, so yeah, there's that. Oh yeah, I actually wrote that in the original in the original presentation. As you can see, I'm quite excited about this. So yeah. So in conclusion, that was the progress report. I hope you enjoyed watching it. Hopefully I can edit this down a little bit and make it into a full video. Please let us know if you've watched this and whether you thought it was a good format for us to use. I'm just happy that I was able to produce something and not get stuck in stuck in development hell. So, so yeah, yeah. Thanks for watching, and yeah, catch you in the next one.